Hello everyone, in this video we will learn about geometric means and their properties. What are geometric means? We say geometric means are one or more numbers which are inserted between any two given numbers such that they form a GP. We can say that geometric means if one or more numbers are inserted between any two given numbers such that they form a GP, geometric progression, then such numbers are said to be geometric means. Now we can have two cases for one number and for more numbers. When we insert only one number, that is known as single geometric mean. It is represented by capital G. If we have, let the numbers be A and B, and G is the number inserted between them. G is inserted between them such that A, G and B are in GP. And if they are in GP, then we know the condition that G upon A should be equal to B upon G, the common ratio. If we cross multiply, we are getting G square is equal to A into B. It means G is equal to root of AB. This becomes the single geometric mean between two given numbers. To understand this, we take one example. Suppose we are to find out the geometric mean of 2 and 18. Now we know the geometric mean G is given by root of AB. We can find it here. Root of A means 2, B means 18, that is root of 36, or we can say 6. And therefore we say 6 is the geometric mean of 2 and 18. Like this we can find out a single geometric mean between any two given numbers. Now the second case is to insert more than one geometric means between A and B. Let it be n. So we are inserting n geometric means between A and B. We write to insert n geometric means between A and B. We have to consider the geometric means, as we have learnt that we are representing the geometric mean by capital G. So we will take these also by capital G. So we write let the geometric means be G1, G2, G3 and Gn. Then according to the definition of geometric means, they will form a GP. It means A, G1, G2, G3 and so on Gn and B are in GP. How many number of terms are there in this GP? They are n plus 2. How it is? As we insert n geometric means between A and B, n are these terms and these are two terms, so they become n plus 2. So we can write the total number of terms is equal to n plus 2. And n plus 2th term is the last term, that is B. A n plus 2 is equal to B. Suppose the common ratio, let the common ratio be R. Then we know the formula for an, that is ARN minus 1. We already learnt this in previous video. According to this, here this term will be A into R power n plus 2 minus 1. This is n plus 1. So this is A into R power n plus 1 equal to B. Can we say then R power n plus 1 is B upon A? It means we can find out the value of R by B upon A power 1 upon n plus 1. We can also say n plus 1th root of B upon A. And after finding the common ratio, we can find out all the geometric means. So we can write therefore G1 is A into R, multiply R in this. G2 will be equal to A into R square, multiplying R in this. G3 is AR cube. And so on we find Gn will be equal to AR power n. Now we have to understand one difference here. If you remember, the nth term was given by A into R power n minus 1. That was power was 1 less than the number of term. In this case of nth geometric mean, the power of R is same as the number of the geometric mean. That is Gn is equal to A into R power n. This is the way we can find out any number of geometric means between any two given numbers. We discussed now one example on inserting more than one geometric means between two given numbers. So the problem is insert 5 geometric means between 3 and 192. To find the solution of this, we will follow the same procedure what we have learnt to find n geometric means between two given numbers. So the numbers which are given to us, they are 3 and 192, and we have to insert 5 geometric means. So we write, let the geometric means be G1, G2, G3, G4 and G5. Then these 5 with these numbers will be forming a GP. Implies that 3, G1, G2, G3, G4, G5 and 192 are in GP. We can see here there are 7 terms in this. Number of terms is equal to 7. And what is the 7th term? That is 192. 7th term is 192. Let the common ratio be R. Let the common ratio be R. Then A7 is A into R to the power 6, and that is equal to 192, because we know the formula of general term AN equal to ARN minus 1. A is 3 here, so this is 3 into R power 6 is equal to 192, which implies that R power 6 is 192 upon 3, which is 64. And we know 64 is 6th power of 2. Comparing this, we can find R is 2. So we know the first term 3, we know the common ratio R, that is 2. We can find out all these geometric means, and therefore we can write G1 is 3 into 2, that is 6. G2 is 6 into 2, that is 12. G3 is 12 into 2, that is 24. G4 is 24 into 2, that is 48. And G5 is 48 into 2, that is 96. This is the answer. We can verify the answer by multiplying this 96 by 2 and we find it is 192, which is the last number given to us. Like this, we can insert any number of geometric means between any two given numbers. We come to the properties of the geometric means now, and the first property is the geometric mean between A and B is G, that is root of AB. But if A and B are of opposite signs, means one is positive, another is negative, then the geometric mean does not exist. Why it is? Because in such case the product A into B is less than 0, and then root of AB will be imaginary. If it is an imaginary number, certainly this does not exist between the real numbers, and that's why we say geometric mean does not exist. The second property is, if n geometric means are inserted between A and B, then their product is equal to the nth power of the single geometric mean of A and B. If n geometric means are inserted between A and B, then their product is equal to the nth power of their single geometric mean. To prove the second property, we go for the proof like this, that we consider the n geometric means between A and B. Let the geometric means between A and B be G1, G2, G3 and so on Gn. Then we know that they are to be in AP. This implies that A, G1, G2, G3, Gn and B are in GP. We have already learnt that the common ratio in this case comes as n plus 1th root of B upon A. And after finding R, we can find out all G1, G2, G3 and so on. Here G1 is AR, G2 is AR square, G3 is AR cube and Gn is AR to the power n. The product of these numbers will be G1 into G2 into G3 into Gn. We substitute these values here, that is AR into AR square into AR cube into AR power n. If we multiply them, we are finding A comes n times, so this becomes nth power of A. And the powers of R are added 1 plus 2 plus 3 plus so on up to n. This is sigma n, sum of n natural numbers, and the formula for this is n into n plus 1 by 2. So the value of this comes as nth power of A into power of R will become n into n plus 1 by 2. Now we substitute the value of R. This comes as B upon A whole power 1 upon n plus 1, and the power of it is n into n plus 1 by 2. We know that the powers will be multiplied, so this comes as A power n into B upon A whole power 1 upon n plus 1 into n plus 1 by 2. This n plus 1 and n plus 1 cancel. So we are left with A to the power n by 2 into B to the power n by 2, which can be written as A into B power n by 2. Can we also write this as a root of AB to the power n, which is G. So this is G to the power n, because we know here the single geometric mean between the numbers A and B is given by root of AB. So like this we can find the proof of the second property, that if we insert n geometric means between A and B, then the product of these geometric means is equal to nth power of the single geometric mean between them. In the next video, we will learn about the types of geometric progressions and about the infinite GP. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.